Good afternoon, Shady Grovers. Here's Miss Mesa. I'm coming to you today from my utility room because I am wanting to do a science experiment that I learned this week from a new friend that I made. Her name is Sarah Beth Johnson, and she's a county 4-H agent, extension agent in Arkansas. And I saw her doing some demonstrations, so I've made contact with her, and she's given me some great experiments for us to do. So that made me decide I want to do like a Saturday science fun day with Miss Mesa. So I'm a little nervous about it because I don't teach science, but you guys all know Miss Mesa loves a good experiment, right? So this experiment's going to call for me to have to go turn out the light and be in a dark room to show you something later on. So my utility room was where I had to choose to do it. So today we are going to do what's called blobs in a bottle. Basically, we're going to make our own lava lamps. How cool is that going to be? And it's really simple. You probably have most everything to do it with at your house. All you're going to need is a clear like water bottle or Coke bottle. Just make sure it's clean. You need 3/4 cup of water. I've already put the water in mine to keep me from making a mess. You will need some vegetable oil, and you need some little fizzy tablets, maybe like Alka-Seltzer. I just got the knockoff Dollar General brand because I just wanted this to be a cheap experiment. And then some food coloring. Miss Sarah Beth said they like to use red, so I've got the red, but I just got some food coloring from Dollar Tree. So as you see, this is a pretty cheap experiment to do, okay? So here it is. The first thing we do is we pour the water in the bottle. Like I said, I did that before I came back here because I didn't want to make a total mess, okay? And then you need to use a measuring cup or a funnel to pour vegetable oil into the bottle until it's almost full, okay? Now we're going to hope I can do this without making a mess because I couldn't locate my funnel a while ago when I was doing my experimental one. I didn't make a mess with it. I probably will while I'm on camera, right? But we're going to just add the vegetable oil to it till it's almost full. There you go. Now, what do you notice about that? The water stayed with the water and the oil stayed with the oil. Do you know why the oil stayed above the water? I learned this lesson too. All right, so the oil stays above the water because the oil is lighter than the water, or more specifically, it's less dense than the water. Now when you're doing this, you might have to wait just a minute or two. Ours separated out pretty quickly, okay? So see, the oil and the water, they don't mix. And it's this big word, the reason why is this big word called intermolecular polarity. Intermolecular polarity. That's kind of a big word. But basically what it means is that the water molecules are attracted to other water molecules. They get along fine. Just kind of like two magnets are attracted to each other. You know, if you take a magnet and you put it on something else that's magnetized, or take another magnet and put it to it, they're attracted to each other. Well, that's the same thing with the water. Water molecules are attracted to water molecules, okay? The oil molecules are attracted to other oil molecules. They get along fine. But the structures of the two molecules, they don't allow them to bond together. Okay, that's just simple terms. That's easy Miss Mesa terms. Don't ask me the big, huge, specific words. I'm sure somebody else could probably tell you that. But that's just basically it. Water molecules are attracted to water molecules. Oil molecules are attracted to oil molecules. Okay, now we're going to add 10 drops. I'm reading my instructions here. Make sure I don't mess it up. To add 10 drops of the food coloring, okay? Now, watch. This food coloring is going to pass through the oil and go to the water. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look at there. See how that passed through? And it goes down to the water. Okay? I got a big glob of it in there, but look, up there it went. It all went down to the bottom. All right. Everybody see that? How cool is that? Our water's still separated from our oil. Now, here's where the activity's fixing to happen. My packs had 2 of these in it, but I only need half of it, so I'm going to break it in half. One broke in there, but we can use it later. Now watch what happens when I put that antacid in there. Watch, can you see it? It's starting to all bubble up. See that red going up through there? Making your own lava lamp. How cool is that? See it spurting? That's what a lava lamp looks like, right? So what do you think happened when we added that tablet piece? Look at it, it's really going good now, isn't it? It sank to the bottom and started dissolving and creating a gas. And as those gas bubbles arose, they took some of the colored water with them. Then when that blob of water reached the top, the gas escaped and went down, and down went the water. Pretty cool, huh? Now you can put your lids on these and store them. Then all you have to do if you want to do it again is drop another tablet in there. Now, what I'm fixing to show you is the cool part about what it's like when you turn the light out. So, let's see if I can do this. Alright, so I'm going to turn the light out and drop my fizzies in there and put the light up on it. Look how it looks glowing in the dark. Pretty cool, huh? See it? And there you go. There is your own personal lava lamp. Look at it. Look at it. That is just the coolest thing. I went and woke Mr. Clayton up a while ago to show him how cool this was. All right. So, you guys know how to make a blob in a bottle, all right? So let me know if you try it out. Have your parents email me or send me a picture of your blob in a bottle through Dojo or emailing me, okay? You guys have a great Saturday, and maybe next Saturday I'll come up with another Saturday Science Fun Day with Miss Maiza. All right? See y'all later. Bye.